Can a global alliance truly stand against the rising tide of sophisticated hackers?
Hmm.
And what would it even mean to operate on a high-trust internet?
Yeah, these aren't just theoretical questions anymore, are they? They're really shaping our digital lives.
Exactly. So today we're plunging headfirst into this pretty complex landscape.
Welcome. And look, this isn't about trying to scare anyone. It's more about, equipping you, our listener, with a clearer picture of the threats.
Right. The threats and maybe some of the solutions being kicked around.
Exactly. We've pulled together a few different sources here to give a nuanced perspective without getting totally bogged down in the weeds.
Yeah, we've got articles looking at the big picture, global cybersecurity, this idea of a high-trust internet.
Which is fascinating.
It really is.
Yeah.
And we're also digging into the details with a book about how ethical hackers do their reconnaissance.
Which, of course, tells us a lot about how the malicious hackers operate, too.
Good point. And then there's another book looking at vulnerabilities in modern web apps, the client-side stuff.
Stuff that maybe doesn't always get the headlines, but can be uh, super effective for attackers.
Right. So our goal here is to kind of synthesize the key insights from all this.
Yeah, to move beyond just saying cyber attacks happen and really try to understand how.
How they work, how they're executed.
And by looking at both the attack methods and the proposed defenses, we can hopefully get a better handle on where things stand now and maybe where they're heading.
Okay, so to really get a grip on the challenges, we kind of need to think like the attackers.
Hmm.
Our book on ethical hacker reconnaissance gives us a peek behind that curtain. What actually motivates these people? It's not always the hoodie in the basement stereotype, right?
Not at all, no.
Yeah.
I mean, sure, some might be driven by the pure challenge of it, breaking the code.
The intellectual puzzle.
Right. But a huge driver, and it seems to be growing, is just plain financial gain. Selling stolen data on dark web markets, for instance. That's a big business now.
A whole criminal economy based on stolen info?
Pretty much. The data they gather fuels all sorts of other crimes.
And before they even launch an attack, there's this whole phase, reconnaissance. He said it's like casing a joint.
That's a good way to put it. Yeah, reconnaissance is all about intelligence gathering. It's the homework phase before the attack, building a profile of the target.
Okay.
And our source breaks it down into two main types, passive and active. Passive is like gathering publicly available info without directly poking the target. Think OSINT, open source intelligence.
OSINT. Right. So what kind of digital breadcrumbs are they picking up passively?
Oh, loads of stuff.
Uh-huh.
The internet's full of public records. DNS records, for example, they're like the internet's phone book, linking names to server addresses.
Okay.
Then there's OHO-IS data, which shows who owns a domain name,
Yeah.
digital certificates, the things websites use for secure connections. They can reveal related domains, company details, even things like IP address ranges or what kind of servers are being used, if that info's public. And beyond that, the book mentions closed sources too.
Closed sources? Like what?
Things like paid threat intelligence feeds, or even, information bought and sold on the dark web.
Wow. So they can build a pretty detailed picture before even making direct contact. What happens when they shift to active reconnaissance?
Active recon means they start directly interacting with the target systems.
Okay. Poking around.
Exactly, like
Yeah.
scanning the network to find open ports. Think of them like open doors or windows.
Right.
And identifying what services are running on those ports. Is it old software? Is something and maybe vulnerable? That's the kind of info they're after.
The book mentions setting up a virtual lab. Things like VirtualBox, Kali Linux. Why is that important for understanding this?
The virtual lab. It's basically a safe sandbox. It lets ethical hackers, or us, try to practice these techniques without actually breaking anything or attacking real systems.
A safe playground.
Exactly. Tools like Kali Linux are packed with security tools, like a digital Swiss Army knife. OSINT VM is set up specifically for that open source intelligence gathering. And then you have vulnerable practice apps like OWASP Use Shop or Metasploitable 3 that you can legally and safely attack within your lab.
Got it. The book also mentions sudo.
Yeah, sudo is just a basic Linux command. It lets you run programs with higher privileges like an administrator or root. A lot of these security tools need those extra permissions to work properly.
And OSINT keeps popping up. Open source intelligence. Why is it so powerful?
It's the sheer volume of data available now. Attackers can pull together information from search engines, social media, public records, you name it. You can build surprisingly detailed profiles.
Scary.
Yeah. And the book points a finger at data brokers, too. Companies that collect and sell personal data from website cookies, apps, public info. That becomes intelligence for attackers.
So it's not just the technical stuff, they're looking at the organization too.
Or absolutely, they want info on the people.
Hmm.
Employee contacts, email addresses, phone numbers, gold dust for targeted phishing attacks, spear phishing.
Trying to trick specific people.
Exactly. Even finding an org chart online can help them figure out who to impersonate or who holds the keys to the kingdom.
It's kind of mind-boggling how much data is out there and how bits and pieces can be put together. The book says ethical hackers spend a lot of time just gathering this stuff.
They do.
Yeah.
But just having the raw data isn't enough. The real skill is in the analysis.
Making sense of it all.
Right. Finding the patterns, connecting the dots, turning that mountain of data into a clear picture of the target's weaknesses.
Now, if you are doing this kind of reconnaissance, ethically or otherwise, you probably don't want people knowing it's you. The book talks about anonymizing your activity.
Yeah, that's crucial. The main ways are VPNs and TOR.
VPNs, virtual private networks.
Right. They encrypt your traffic and route it through their server so it looks like you're connecting from somewhere else. Masks your real IP address.
You can use commercial ones or set up your own.
Yep. Setting up your own gives you maybe more control, but commercial ones are easier. The key is the exit point where your traffic seems to come from.
And TOR, the onion router.
TOR goes a step further. It bounces your encrypted traffic through multiple volunteer-run servers called nodes. Layers of encryption, like an onion, makes tracing back to the original source much, much harder.
Complex.
It is. The book also mentions proxy chains briefly, which is another way to route traffic through multiple proxy servers.
Okay, let's get into some specific techniques. Domain and DNS intelligence gathering sounds foundational.
It really is. A website name gets translated to an IP address by DNS, so looking at a target's domain and DNS setup tells you a lot.
How do they do that?
Simple things first, like using Google search operators.
Yeah.
Like site to search only within a specific website.
Yeah.
There's also the Google Hacking Database, the GHDB. It's a collection of search queries designed to find sensitive information that websites might accidentally expose. Powerful, but the book rightly warns against misusing it.
Right, ethical use only. And the DNS servers themselves. Root servers, INA.
Yeah, the root servers are at the top, managed by INA. They direct traffic down the chain to the right servers for .com or .org or whatever, eventually finding the server hosting the site you want.
Okay.
And examining those digital certificates websites use for HTTPS. It can also give away domain info, serial numbers, stuff like that.
The book mentions specific tools, Recon and DNS Recon.
Yeah, tools to automate this stuff. Recon is like a framework. It has modules. One uses Bing to find subdomains, maybe even guess their location. DNS Recon focuses specifically on grabbing all sorts of DNS records for a domain, like querying Google's DNS for apple.com. That's the example used.
Okay.
It also talks about DNS zone transfers. If a server is misconfigured, an attacker might be able to download the entire DNS record for a domain. That's bad.
Yeah, sounds like giving away the map.
Pretty much. And for broader automated OSINT, the book suggests looking at Spiderfoot.
Okay, shifting gears from the technical side to people side, gathering people and signals intelligence. Sounds like spy stuff.
It kind of edges into that, yeah. Intelligence is about finding info on individuals in the target organization. Help. Social media, definitely. Tools like Sherlock can search for a username across tons of platforms, see what they share publicly, maybe find links to data breaches they were in.
Oh, right.
Analyzing Facebook profiles, public groups, pages can reveal connections, interests, even metadata in photos, EXIF data. It can sometimes contain GCIN's coordinates, timestamps.
Seriously, in photos?
Sometimes, yeah. Tools like Google Images or Google Lens can help identify people or places from pictures. And Google Maps, you can do virtual recon of a physical location. The book uses Twitter HQ as an example, checking out the satellite view.
And those credential leak databases. Have I been found?
Huge resource for attackers. They check if email addresses or phone numbers have shown up in known breaches.
Giving them passwords to track.
Exactly. Or just confirming an email is valid. Or maybe crafting a better phishing email based on what services the person used. Intelligence X and Dehashed are other examples mentioned.
Wireless signals intelligence. War driving. With a Raspberry Pi.
Kind of, yeah. You can use a small computer like a Raspberry Pi, maybe running Kali Linux, and a tool like Kismet to just passively listen to Wi-Fi traffic nearby.
What do you learn?
Network names, ESIDs, the access point addresses, BSIDs, even the addresses of devices connecting or looking for networks stations. Gives you a map of the local wireless environment.
Okay, so that's all mostly passive. Then comes active reconnaissance, actually interacting with the target.
Right. Now you start knocking on doors, digitally speaking, identifying open ports, figuring out what services are running. Banner grabbing is trying to get the version info of those services.
To check for known vulnerabilities.
Exactly. And ping sweeps using ICMP just to see which machines on the network are actually online and responding.
And Nmap. That name comes up constantly in security.
It's the workhorse. Incredibly versatile network scanner, does port scanning, tries to guess the operating system, detects service versions. It can even run scripts for specific tasks, like grabbing info from Windows file shares, SMB shares. That's the nbstat.nsc script example.
Can you hide your tracks with Nmap?
To some extent. It has options to spoof your MSC address, make it look like the scan came from somewhere else. Or fragment packets, split them up, which might sometimes bypass simple firewalls. Options like edit spoof Mac and F.
SMB, Windows file sharing, you mentioned that. Why is it a focus?
Because it's everywhere in Windows networks, often involves shared data, and historically has had quite a few vulnerabilities. Tools like Sun Client try to list accessible shares.
Okay.
And Nmap has specific scripts just for finding known SMB vulnerabilities, like using script-om.
And active wireless recon goes beyond just listening.
Yeah, it might involve sending out probe requests yourself, trying to actively get responses from access points to learn more about their configuration or connected clients.
The book also covers vulnerability assessment tools. Nessus, Greenbone. How do that fit in?
So once you have a map of the systems and services from reconnaissance, these tools automatically scan for known weaknesses.
Like an automated checkup.
Kind of. They have huge databases of vulnerabilities. You point them at the target IPs, and they generate reports showing potential issues, usually ranked by severity, like CVSS scores or Tenable's VPR. Helps defenders prioritize what to fix.
Makes sense. And specifically for websites, what's involved in web app recon?
A lot. You start with basics like the dig command to get all sorts of DNS records, A records for IPv4, AAA for IPv6, MX for mail servers, NS for name servers, and so on.
Okay.
Online tools like Netcraft give you hosting details, IP ranges, technologies used. DNS Dumpster is another one focused purely on digging deep into DNS info for a domain.
Subdomain enumeration and directory brute forcing. Finding hidden stuff.
That's the idea. Finding subdomains maybe not linked from the main site. GoBuster is a tool mentioned for that, and also for directory brute forcing.
Which is just trying lots of common names.
Yeah, using a word list to guess directory or file names. Watching the HTTP status codes is key. 301 means redirect, 200 means you found something. You might uncover admin panels, config files.
Sensitive stuff.
Potentially, yes.
The OS Top 10 gets mentioned. What's that?
What's top 10? It's a standard awareness document, basically. Lists the most critical security risks for web applications.
Yeah.
Super important for developers and security folks.
Right.
Nico is a free scanner mentioned that checks for many common web vulnerabilities, including lots from the OWASP list. And for really comprehensive attack surface mapping, there are frameworks like SN1BOPR or OWASP's own Amass project.
And Wireshark for network traffic analysis, getting down to the packet level.
Exactly. Wireshark lets you capture and dissect individual network packets. Incredibly detailed. Great for understanding network protocols, troubleshooting, or deep diving into how network attacks actually work.
Wow. Okay, understanding the attacker is one thing, but how do you detect this reconnaissance happening? The book mentions recon monitoring and detection systems.
Yeah, so the idea is to have systems watching for these probing activities. Security Onion is a big one mentioned.
What is Security Onion?
It's a whole platform, really. A Linux distribution packed with open source security tools. Things like Beats for collecting data, Oscary to check on endpoints, Wazoo for intrusion detection on hosts.
A whole suite of tools.
Yeah, and analyst tools like Kibana for visualization, CyberChef for data manipulation, Playbook for automating responses, all managed through a central console.
How does it work?
You set it up to monitor network traffic. It has rules to detect suspicious patterns, port scans, vulnerability probing, weird DNS lookups, and it generates alerts. Gives defenders a heads up.
An early warning system.
Exactly. Shows timestamp what rule triggered, severity, source and destination IPs, ports. Critical info for responders.
Okay, that's a fascinating look at the attack side. Let's pivot now to the bigger picture and potential solutions, using our second source, Taming the Hacking Storm. The author has a pretty strong vision, it seems.
He definitely does. He starts off with some, frankly, pretty scary statistics about online crime. Billions of malicious emails daily. Cloudflare reporting huge amounts of bot traffic.
Yeah, the scale is hard to comprehend. And he points out that basic stuff like social engineering, phishing unpatched software, they still work really well.
It's kind of depressing, isn't it, after all these years? He also highlights credential abuse using stolen passwords and how ransomware isn't just about locking files anymore. It's about stealing the data, too.
Data exfiltration, nasty.
Yeah, and he mentions the personal impact, too, like people losing their social media accounts, which can be devastating.
He uses that analogy about home security focusing on stronger doors while ignoring the open windows. What's the point there?
His point is that we might be focusing too much on certain security layers while consistently failing at more fundamental ones. He's been tracking how hacks actually happen for over 20 years, and he lists the root causes.
What are some of those main root causes he identifies?
It's a long list, but key ones are software and firmware bugs, obviously,
Yeah.
social engineering tricking people, malware,
Yeah.
technical impersonation, faking identities or authentication, insider attacks.
Things like messing with data or network traffic?
Yeah, data malformation, network traffic malformation, problems with relying on third-party code or services, simple human errors, bad patching, weak passwords, security checks being bypassed, sometimes even as designed.
Wow.
And now stolen biometrics, deepfakes, and even physical attacks, though they're less common online.
And the motivations behind attacks. Still mostly money.
Mostly, yeah. Financial crime ransomware, theft is number one. What he calls traditional hacking, for kudos, is less common now, often tied to money anyway. Then you have nation-states doing espionage or sabotage, corporate spying, and hacktivism for political or social causes.
So faced with all this, he proposes this high-trust ecosystem. That's his big solution, right?
That's the core of it, yeah. A system he's been thinking about for decades, arguing the current internet fundamentally lacks trust mechanisms.
What are the pieces of it?
Okay, first big one. Require verified trusted identity, or real ID, linking online accounts to a strongly verified real-world identity. He knows unique names are tricky, so it needs unique identifiers.
That alone sounds like a huge challenge.
Whoa, massive. And it needs a whole supporting infrastructure, the high-trust ecosystem. Not just ID, but trusted components all working together. Like how a passport needs trusted postal services in airports to work.
Okay, what else?
Trusted devices, making sure the hardware and firmware are secure. Things like BIOS Secure Boot, which uses certificates to tie the OS to the hardware, protected memory.
Verifying the device itself is trustworthy.
Exactly. And device identity, how websites reliably know what device is connecting. He talks about levels of assurance. Low assurance, like just checking the browser type. Medium, like maybe a work login. High assurance, using things like TPM chips built into computers, which have unique keys.
TPM, Trusted Platform Module, got it.
He also mentions security-bounded cookies, making stolen session tokens less useful. And trusted actions.
Trusted actions, what's that?
The idea is to verify specific actions a user takes. A developer would register an action, like transfer funds, with a global trust assurance service.
A central authority?
Kind of. This service would rate the trust level of the app performing the action. When you do the action, the website checks with the service. Is this user on this trusted device using this trusted app allowed to do this?
Complex verification.
Very. Then there are trusted networks that enforce policies, like requiring up-to-date patches or anti-malware. Different from zero trust, which assumes no trust initially. He mentions man-in-the-middle attacks is why we need trusted networks, and notes HTTPS alone isn't foolproof.
And the trust assurance service is central to all this.
Absolutely. It's the verification hub for identities, devices, apps, actions. It would have lookups, caches, public all block lists.
Who runs it? Who sets the standards?
Good question. He argues we need a new Internet Security Global Alliance because existing bodies like IETF or W3C or governments aren't set up for the speed and focus needed.
A new global body for internet trust.
That's his proposal, focused on root causes, open standards, risk ranking, investigating incidents, using paid experts. Ambitious.
Very. How does he think this system tackles those root causes of hacking he listed earlier?
He maps it against the Stride threat model, spoofing, tampering, etc. He argues verified ID helps against spoofing and social engineering. Trusted devices help against malware and tampering. But he admits some things, like relying on third parties, are only partially fixed. Even trusted parties can get hacked.
The big elephant in the room with verified ID is privacy, right? Especially in certain countries.
He tackles that head on. Yes, it's a huge risk. Verified IDs could be abused by authoritarian regimes for surveillance or targeting dissenters. Guaranteed anonymity becomes very difficult.
So what's the answer there?
He talks about maybe attempted anonymity, using pseudonyms still linked to a verified ID, but admits it's not a perfect solution for everyone needing privacy. It's a trade-off.
And why hasn't something like this happened already? Who pays?
He uses the tragedy of the commons analogy. Everyone benefits from a secure internet, but no single entity has the incentive or power to overhaul it globally. For funding, he sees new organizations and commercial services emerging for ID verification, device checks, running the trust service. Governments might handle the highest trust levels.
He also stresses secure coding and better patching, even with this system.
Absolutely. They're fundamental. Preventing bugs in the first place is key. He talks about memory safety issues, using safer programming languages, banning dangerous functions, bug bounties, better developer education.
And patching.
Critical. There are just so many vulnerabilities now, including 0 days. He suggests focusing patching efforts on the bugs actively being exploited, like CISA's known exploited vulnerability list, making patches easier to roll back, using the cloud to patch more efficiently.
What about global cooperation on cybercrime itself?
That's another tough one. Different laws, different enforcement priorities between countries make it hard. He mentions the U.S. CFAA law and the ongoing push for a UN convention against cybercrime, but notes how difficult international agreement is.
Okay, let's shift to our final source, the Hacker's Codex, focusing on client-side web vulnerabilities, things happening in the user's browser.
Right. The author argues modern web apps do so much logic on the client side now, in the browser, and attackers exploit that.
Why focus on client-side?
Because these attacks can be very effective, easy to scale, hit lots of users, and sometimes they get rated as lower severity by defenders, so they might not get fixed as quickly.
Sneaky. Okay, give us some examples from the book. HTML injection.
Sounds simple, maybe low severity, but great for phishing. Injecting malicious HTML into, say, a contact form field. That could make a fake email look totally legitimate when it arrives in someone's inbox.
Tricking people into clicking links or giving up info.
Exactly.
Host header injection. That's
Not
not
bad.
technical.
It involves messing with a host header in an HTTP request, the part that says which website you're trying to reach. If the server handles that badly, maybe you could trick it into sending a password reset link to your domain instead of the user's. The book uses VestaCP and Burp Suite as an example.
Ouch. Username enumeration using SSNs. That sounds really bad.
It is. It highlights how client-side security, like trying to encrypt data in the browser or limit login attempts, can sometimes be bypassed.
Oh.
By understanding how SSNs are structured, maybe using public death records to narrow down possibilities using social media info, attackers could potentially brute force SSNs, even if there are client-side protections like Google's Shape trying to stop bots.
Exploiting CORS misconfigurations. We mentioned CORS before.
Yeah, cross-origin resource sharing. It controls how websites from different domains can interact. If it's set up wrong, a malicious site might be able to steal data from another site the user is logged into. Like if the server just reflects whatever origin the attacker sends. The book also mentions how subdomain takeovers or XSS flaws can make CORS issues even worse.
CSRF cross-site request forgery. That's an old one. Still relevant.
Still relevant. It tricks a logged-in user into doing something they didn't intend to, just by visiting a malicious page or clicking a link.
Yeah.
The book talks about common defenses like the double submit cookie pattern, but also ways to bypass them using those other flaws like subdomain takeovers, CORS bugs, XSS.
Redirection bugs or open redirects. Using a legit site to bounce users to a bad one.
Classic phishing assist. A website takes a URL as a parameter for redirection, but doesn't check it properly. Attacker crafts a link using the trusted site's domain, but it redirects the user to their malicious site. The book mentions cloud local redirects as one example.
And XSS cross-site scripting, the big one.
Probably the most famous web vulnerability, injecting malicious JavaScript into a website, which then runs in the browsers of other users visiting that site.
What can it do?
Steal session cookies, change how the site looks, redirect users, capture keystrokes. Lots of bad stuff. The book covers finding XSS, how JavaScript frameworks affect it, bypassing firewalls, WAFs, using things like Evil or the Fetch API. Also related attacks like clickjacking.
CSV injection. That sounds different. Affecting spreadsheets.
Yeah. Injecting formulas into data that gets exported as a CSV file. If someone opens that CSV in Excel or Google Sheets, the formulas might execute automatically.
Doing what?
Could exfiltrate data, run commands on the user's machine.
Hmm.
The book mentions stored CSV injection too, where the bad formula comes from the database itself.
HTTP desync request smuggling. That sounds like server stuff.
It is fundamentally about inconsistencies between how front-end proxies and back-end servers handle HTTP requests. But attackers trigger it from the client side by sending specially crafted requests. It can lead to bypassing security, hijacking sessions, highlights the complexity of modern web stacks.
And finally, web cache poisoning. Tricking caches into serving bad content.
Yeah, really clever stuff. Web caches store copies of content to speed things up. Poisoning involves tricking the cache into storing a malicious version of a page or a resource,
How does that work?
often by manipulating parts of the request that the cache doesn't use to decide if it has a copy unkeyed inputs, like certain headers or parameters. An attacker sends a request with a malicious payload linked to an unkeyed input, the cache stores it, and then serves that malicious version to legitimate users requesting the same resource. The book mentions Paraminer as a tool to find these unkeyed inputs.
Wow. This deep dive has been, well, eye-opening. A bit overwhelming, maybe. We've gone from attacker planning to huge systemic internet problems to these specific web app flaws.
We really have. It shows how multi-layered the threats are, right? From that initial recon, gathering intel,
Right, like casing the joint.
to exploiting very specific bugs, whether on the server or, as we just saw, right there in your browser. And then we look at that big vision for high-trust internet.
Verified IDs, trusted devices.
Yeah, a potential future path.
Yes.
Alongside the fundamentals that are always important, like secure coding and keeping things patched.
It definitely drives home that there's no single silver bullet here. It's got to be layers, tech solutions, user awareness, global standards, maybe.
Absolutely. It's an ongoing battle on many fronts.
So to wrap up, maybe a final thought for you, our listener. Thinking about everything we've covered, the attacker methods, the big picture challenges, the specific bugs, the potential future systems, what's the one aspect of internet security that worries you the most right now? And maybe flip that around. What single change, if we could actually make it happen, do you think would have the biggest positive impact on making us all safer online? Something to think about. Maybe dig into zero trust concepts or check out what organizations like CISA are recommending. Lots to explore.